Welcome to the largest water show in North America and maybe in the world. Welcome to WEFTEC. Welcome to New Orleans. Today we'll cover a Series B for a company together with its CEO and its lead investor. We'll get to know 3 new technologies. I had no clue how they work before entering the building. And finally, we'll get an update on PFAS destruction. But before that, let me get you up to speed with WEFTEC. WEFTEC was first held nearly 100 years ago when the Federation of Sewage Works Associations held its first annual meeting in Chicago. In 1950, they changed their name to the Federation of Sewage and Industrial Waste Association. In 1960, they left place to the Water Pollution Control Federation. In 1991, here comes the Water Environment Federation. And in 2024, I'm attending my first WEFTEC. Yes, it's exactly the same level of news, if you ask my mom.
My son is the greatest gift of my life.
WEFTEC is actually the combination of a trade show with exhibitors showcasing the latest water tech, which is where we will spend most of our time today, and a conference that's offering comprehensive educational programs across all aspects of water and wastewater treatment. On the exhibition side, you'll find about 1,000 companies and over 20,000 people walking the floor and networking over a glass of water, or more often, a beer. For a while, it's been alternating every year between Chicago and New Orleans. It sounds like WEF is shaking things up a bit from 2028 on by adding new cities to the roster with Anaheim.
I've always wanted to visit Disneyland.
And later Atlanta in 2030.
You're ready to go on your Mormon mission.
But for this week, we're still in Big Easy. There as well, a premiere for me. And after an opening session that encouraged everybody to tell their stories, welcoming my podcast alumni Ralph Exton as the new executive director of WEF, and listening to some great local music, it's time to kick off our episode for today with Aqua membranes. So now that we're all up to speed, let's go inside. We have a Series B to cover. Let's go meet Craig and Steve. While I walk to their booth, if you remember, when Craig Beckman, the CEO of Aqua Membranes, was my guest last year, he told us that
we're going to be doing fundraising this summer to build a new 10X factory.
We're in October, the summer is over, and boy, did they do fundraising. As Craig leveraged the opening day of WEFTEC to share the news that Burnt Island Ventures, represented by partner Steve Kloos, was leading their Series B. According to Burnt Island's website, Aqua Membranes might be the first step change improvement in reverse osmosis in decades, with low barriers to adoption, strong IP, a nicely blue ocean, a great team doing weightlifting on the trade show. Okay, that's not in the press release, but on LinkedIn. And you know what? To know more, let's go meet Craig and Steve.
Today actually is the close of our B Series fundraise. This round is to fund our next level of growth. Burnt Island Ventures is actually leading our B Series. Super excited about that. And it allows us to go to the next phase of production. We're in production now, but in a small scale. They're helping us fund a new facility that'll be somewhere between a 10 and 20x increase in production.
So you're rebuilding the Osmonics Mafia.
Perhaps. Right now we're building off of membrane technology. Osmonics ended up valves and systems and lots of other stuff. We'll see if we end up building, but Steve's background, my background is on membrane technology, and membrane's been around for 50, 60 years. Membrane flat sheet has gotten so much better, but the design of the element still is substandard. We feel like having them as a lead investor will bring as many leads as anything we've done so far in a case study.
If I'm right, the way that you work at Burnt Island is that one of you takes the lead, so whether Tom or Christine, in this case, would that be you, Steve?
Yeah, so I will be joining the board of Aqua Membranes and being most closely involved, but when Burnt Island invests, everybody's involved.
When we discussed on the podcast some months ago, a spacer for membranes were already cool, but what's changed now which triggers the Series B?
A couple of things are driving that. One, customer adoption, picking up in food and beverage, in mining, in recycle applications, more and more customer demand pulling on us. And some of them are like really big customers that we'll be making public soon that are asking the question like, all right, if we start down this path with you, are you going to be able to keep up? We'll give you 100 elements now and 1,000 soon and then 5,000 in the future. What happens if we want to order 5,000 elements? Right now, that's a problem for us. It's a good problem to have. And then the other thing we're expanding into is seawater desal. Very soon we'll be releasing data from our first seawater install. That's actually a pilot running in Saudi Arabia. Part of the Global Innovation in Desal Award we won last year was the pilot. That pilot is actually starting up this month. And we're really excited to share that data. And we think the combination of big customers adopting faster with seawater is really going to drive the adoption where we need more volume. We continue every month to sell out the volume we've got. and that's with our small facility in Albuquerque. So we're announcing we've got a new facility that'll be opening in Knoxville, Tennessee, that will be between 10 and 20 times larger. The square footage is 20 times larger, so we're going from 10,000 square feet to 200,000 square feet. Won't be full yet, but that's our aspiration, to fill that whole factory.
Why do you want to keep the entire value chain internally? Because you could be licensing the technology, you could be selling printers, but instead you decide to 10x your production capacity. So why?
I think it's important for us to have a best-in-class, high-speed manufacturing to prove that it'll work. Part of our long-term business model is licensing. That's a big part of the plan that we're going to really lean into Steve and his team on helping us understand that strategy of where do we license versus where do we sell direct. But if we license, people like Steve and our current CTO, TJ Kurth, are like the perfect people to tell us, all right, like in your former job, you'd be the person we'd be selling this to. And both Steve and CJ come to us and say, I'd want to see it working on high volume, high yield over a long time. We started with subcontractors, which we're still doing today. I don't think we get that same credibility. We don't get that same, it works. This new factory will be a state-of-the-art, very automated, going from printing, auto winding, testing, all the way through, so that if there is a market segment, wastewater treatment for ZLD in India, that we want to license instead of sell direct, that customer can come to our factory, see it in production and say, oh, that's what it looks like.
I'd also say, I think when you make your own product, the learnings that you get from it, what they're making now is a really high quality, high yield product. But there are continuous improvement learnings you get that you're not going to get if you just license that out. So for the company to be able to ramp up production, a lot more automation, all the continuous improvement, sort of the next gen stuff that's coming, to be able to make that, implement that yourself. When you have that, you can go teach the licensees to do that. You have to turn those learning cycles and improvements yourself by doing it.
Yeah.
One word you didn't mention so far is standardization. Today, a good part of your added value is that you can solve customer-specific problems with specific spacers. I'd say it lends itself, of course, very well to an artisanal factory, but with a 10x larger capacity and potentially 20 times larger soon, do you standardize your operations and stick to, 5 designs? Or can you keep some flexibility and customization capability?
Yeah, great question. How much do you customize exactly what the customer wants per application versus get good at making one thing repeatedly? And it's an optimization curve, because every customer, especially in today's culture, wants everything bespoke just for them. Like they want an artisan membrane manufacturer that's in their backyard casting and coating, but that's not practical because it costs $5,000 for every membrane element. So they want that, and they want to spend $300 or $400 per element. We can't have both. But I think we do have the opportunity to balance those two against each other. Today, we only have 2 products. I think next year at this time, we'll have 3 or 4 products. It's going to be 2026, 2027 before we would get to the point of saying, you want a bespoke membrane element? Now we can do it. You got 8 options of flat sheet, 22 options of patterns, and pick what you want. And we've determined over time, this is the one for that application. But I would say that today, we had to pick something that was in the middle that gave some benefit for energy reduction, some benefit for fouling reduction, and some benefit for productivity. And so that's where we're still at today as we're learning. But I think in the near future,
say 5 years down the road, just down the road sometime. So Aqua Membranes is developing, and they have developed really great insights about, for specific water to be treated, the optimal spacer pattern might be for that. So you can imagine, let's say that there's a mega desal project that's happening. Aqua Membranes could eke out the last very bit of optimization by coming up with a custom design for that. And this is down the road and a massive project where it makes sense to do something special like that. But all the learnings they're getting right now and all that continuous improvement potential in the future. But right now, stick with 1 or 2 products. Makes a ton of sense.
And you could really geek out even more, which again is the reason we love Steve as an investor. Like we get questions about concentration polarization. How do you make sure you get good mixing at the membrane surface so you're not letting too much salt with the permeation going through the membrane? You have to have the right mixing, and that gets into these super complicated fluid dynamics of the spacer thickness. In the not too distant future, you could have 22 different patterns just in seawater. But we're not there yet. We need a lot more installations. We need a lot more learning. And that's another reason for building our own factory, that we want to control that design.
Let's talk money. dollars and cents.
You signed today, so that means the clock starts ticking and now you have 6 to 10 years. As an investor, in those 6 to 10 years, what do you need to see to call it a success?
So I think one reason that we're really excited about Aqua membranes is what they're replacing is the mesh spacer, that it's hard to find somebody that would stand up and say that this is a purpose designed, great technology to use for the functions that it has. We think that this really has got broad applicability. And so I think what we're trying to see and what we're hopeful for in this time frame is to see Aqua membranes begin to get adopted in more places. When we step back and we think of the mesh spacer technology, it's hard for us to see large amount of the market sticking with something like that over time relative to the Aqua membranes. Innovation is just a huge step change improvement. I think it's hard to find a downside in it. It just needs to get adopted. So we're really looking for kind of a pragmatic approach towards the market and market expansion. We don't have to try to hit home runs day one or throw Hail Mary passes. Let's just be pragmatic, make some progress here, start to get some adoption. I think that's what we're excited about.
What we've talked to Steve and his team at Burnt Island about is the standard. That's the term we've started throwing around at Aqua membranes. We want to become the standard. In spiral wound membrane elements, today, the extruded mesh is the standard. We want to become the standard. Polyamide is now the standard chemistry, but it wasn't when Steve and I started 30 years ago.
A million years ago. Nice to see you again, buddy.
And so we want to become the standard, and we get that's aspirational and a high bar, but both through licensing and direct sales, we think that that's within sight.
I'm pretty sure you didn't just take a booth at WEFTEC to announce a Series B, so what are your expectations here?
Leads with customers. We're expanding our capacity significantly, so we're looking for customers. Like, we're going to have to sell out this new factory. It's going to be up in production second quarter next year. We're looking for customers to fill it up.
Second quarter next year means the groundbreaking already happened.
The lease is already signed on the building. We'll be ordering capital equipment probably in the next 2 to 3 weeks.
He's had the horses in the barn.
We're going to hit the ground running.
Well, I'd be delighted to be at the opening. Look how I'm inviting myself. So thanks a lot and see you next year, I guess.
Sounds great, Antoine.
Now, one thing which I love to do on trade shows is to walk around and to look for technologies which I don't know yet. I played that game here and I found 3 which you'll tell me in the comments if you knew them better than me. Let's start with VorTech. Actually, John McConomy, VorTech's commercial director, gave me this strong take.
If there were 100 engineers standing here and we had a few minutes to talk to them, 98 of those guys would want to be using this technology.
So let's do the test. Through this video, you'll have a bit of time to talk to the VorTech team. Will you be convinced? I probably was, but how about you? Let me know in the comments. So to start with, what is VorTech?
VorTech deploys wastewater treatment capacity around the world at a lower cost. When you take a treatment plant, aeration is one of the most important processes. Use up to 70% of the overall treatment plant's energy. It's a high maintenance burden in a lot of facilities. So we've developed a groundbreaking platform of technologies that's based on the VorTech to solve these challenges. I'm going to pass you to John, who's going to explain how it works.
So in today's world of wastewater aeration, you have 2 primary means of aerating wastewater. We have a mechanical aeration, which typically is on the side of a tank or on the top of a tank. And it's got some good attributes because you can actually get to the product. You can get maintenance crews to do the work they need to do. And then you have what might be classed as, let's say, the best-in-class aeration, which is fine bubbles, but the technology is at the bottom of the tank. Difficult to access, you can't get near it. And I've spent considerable time ripping out diffuser systems and changing diffusers. I know that world very well. So what we've done at VorTech, we've actually dared to be different, and we've reimagined the world of aeration. And we've taken the best of 2 worlds and married them together. And we're actually creating a fine bubble aeration system, but from the top of a tank, where an operator can access the product should they need to ever do maintenance or change it out. If I walk you through very briefly how it works, we have a product that is pretty much plug and play when it gets to site. There's a few parts that need to be assembled.
You say a few parts, but the prompter behind you even goes beyond that and says 4. So what are those 4 parts?
You have your pump, your draft tube, your circulation chamber, and we have the outlet duct. And those 4 components would arrive on site, typically on the same truck or the same lorry, bolted together, assembled pretty fast, and lifted directly into the tank. We drop it, maybe in one day, the whole thing could be dropped into the tank. And we have a pump in a draft tube or a column. That pump would pull water up from the aeration basin, put it into what we call circulation chamber, and it spins the water at high speed. So it's only the pump velocity with the water that creates the turning. And we now have a cyclone effect within the circulation chamber. This cyclone has nothing in the middle, if you can imagine, it's like a tornado, and therefore with the opening on top of our unit, we have a low pressure zone and it's sucking the air in, the ambient air.
What that allows us to do is bring water to air, as opposed to bringing air to water. to traditional diffused aeration.
So that means we don't need blowers to provide air to our aeration system. We don't need blower buildings or air mains. The ambient air has been pulled in. It's been mixed at high intensity with a high shear, turbulent boundary layers inside here. And then the water's deployed back into the basin with the fine bubbles already ingrained in it. The dissolved oxygen in the tank would increase, and we're constantly pulling water back up, re-aerating it, and dropping it back into the tank. If a client would like to increase or decrease the dissolved oxygen level in the basin, they simply need to ramp the pump up or ramp the pump down. If we want more air, the pump goes faster. If we want less air, the pump goes slower. It's extremely simple in terms of feedback. It's a DO probe telling the pump what to do. We can also have multiple stop-starts on the pump itself, and we can turn the pump off. So we can pull that aeration basin right down into an anoxic environment to go to nitrification, denitrification. The key thing for us, of course, when we're talking to clients is we're providing fine bubbles from the top of a tank. If an operator ever needs to access the pump, they simply walk over to this flange. There are only 12 bolts. It's going to take them 15 minutes to open. They can pull the pump out, have a look at it, change it if they need to change it, put it back again in a matter of minutes, 15, 20 minutes, an hour. If someone had told me that I could do the maintenance on a fine bubble aeration system in an hour, I would have thought they're mental.
So it's elegant. It brings two process fields together, it provides easy maintenance, and you've hinted at how more efficient it may be. But can we quantify those efficiency gains?
We can deal with a lot harsher wastewater, and at our reference sites that we've demonstrated to date, which includes membrane bioreactors, oxidation ditches, completely mixed tanks, we've demonstrated an average of 30% saving versus conventional technology. The big benefit is with this technology, it can last twice as long as a conventional aeration system. And when you combine the energy saving and the maintenance saving, the total life cycle saving in wastewater infrastructure is significant.
Define me significant.
Over a 20-year period, we've demonstrated a projection 25% saving in total life cycle costs. That increases towards 35% over a 40-year period.
35% gains, that's above Paul Kahn's golden bar for traction in his book, The Dynamics of Water Innovation. So it should be flying off the shelves, right?
We are getting a lot of interest all over the world. We're currently in Ireland, UK. We're expanding into Europe with a lot of food and beverage, but also the municipal. We're also expanding in Australia. So there's a lot of interest.
When engineers hear about it, they're intrigued, excited, and there's one or two that have said something along the lines of, why is it taking 100 years for us to actually come up with this idea? So it's of interest to engineers for sure. They get it.
As an example of a benefit that we provided to one of our customers, that customer is very interested in the savings through maintenance and energy. And following commissioning of that product for that customer in a membrane bioreactor, they were originally draining that tank every 1.5 years to access diffusers and send people down into deep tanks, 6 meters deep. The customer came back to us after. It's like, I'm really happy to see the maintenance savings. I'm really happy to see the energy savings. But what I'm absolutely thrilled about is the safety. I don't now have to send my people down into tanks to confined space areas, which are quite dangerous, to access them and maintain diffusers. Yeah, that is one of the major benefits of the technology.
With all these green lights, what are the market barriers VorTech needs to overcome?
One of the biggest hurdles with a young company starting, especially with a new technology, is that we need to reach the world and tell them that it exists. If there were 100 engineers standing here and we had a few minutes to talk to them, 98 of those guys would want to be using this technology. Then it comes down to the rate of adoption. Can they put it into the plant? Do they have the budget to put it in the plant? For the most part, it wouldn't be they don't want to use it, it's just comes down to timing. The plants we've already worked on or the clients we've already sold to or convinced, they're already engaging on second and third and fourth plants. For us, the proof of the pudding's in the eating, so it's pretty important to note that we don't change the process design of a wastewater treatment plant per se. We're providing a different mechanism of transferring air or oxygen to the biology, but the process engineers, we're not telling them to change their approach. You know, it's not a new fundamental way of treating wastewater. All the calculations they would do day to day, they do it going forward. We're basically switching out the old aeration for the new, and we're putting it on top of the tank, so they don't need to drain the tank. In fact, we have a client that's had an existing fixed on-floor aeration system that, let's say, was towards the end of life, and he chose to use the VPA, VorTech's powered aeration system, put it on top, switched off the old one, and it's still in the tank to this day, 3 years later. They won't remove it. They never need to go into the tank again, ever.
So is that the typical use case that you do brownfield retrofit, or do you also do greenfield?
We're both doing new builds and retrofits, and about 50-50 at the moment.
For people that would still be undecided about your 98 out of 100 conviction rate, what would be your killer take-home last arguments that will trigger their positive comment?
In today's age, where we are with the climate, We can't be waiting. If you talk about using the old technologies, you have to drain tanks, fix tanks, re-engineer, lots of blower rooms. We could come to a site, drop something on top of the existing asset, turn it on tomorrow, and we're good to go. I don't think any of us have the luxury of waiting another 5, 10, 20, 30 years. We need to move fast.
We need to accelerate capacity of global wastewater treatment as soon as possible.
Thanks a lot.
Thank you.
Excellent, pleasure. Thanks, Antoine.
And that was VorTech, my first discovery for today. So while I take the WEFTEC trend to my next tech finding, it's time for you to tell me in the comments, honestly, had you heard of that step change in aeration before? On top of all the performance and maintenance benefits Sean and John shared, needless to say, this is by no stretch of the imagination a sponsored segment. It's just my genuine excitement for water tech. I personally even see promising additional avenues to it. Think, for instance, of reusing the waste product of a hydrogen generation, namely pressureless oxygen, that you could suck into aeration tanks with a vortex to further intensify the treatment process. But happy to read your overall thoughts in the comments. For now, let's move to our next discovery, and one that comes with an intriguing name. Ever heard of water with 2 V's? Well, me neither, so let's go check them out.
Well, so water is a name that we think represents what we do. We're trying to deliver clean water for all humankind. And the VV is just a way to say this is a brand that we have that's something different and unique because we have a different and unique product.
Unique and also born from unique parents.
That's correct. So NASA, Stanford, Harvard, lots of people have looked at the technology we're using, but said, while it's the most effective way to treat and clean water, it can't be commercial because it takes too much energy to clean small amounts of water. What we've done is find that formula where we use a small amount of electricity to clean a large amount of water. That process is called advanced low tension electroporation process. Essentially, you're disinfecting water with electricity. So there's no chemicals, there's no filters, so there's no membranes, there's no biologics. Very low energy usage, very clean, very green.
Disinfecting water with electricity. Okay, but where does it fit in a treatment process?
So it fits in a number of different locations. We're at WEFTEC. We're demonstrating our ability to treat water that's coming off of primary treatment and then going through the secondary and disinfection process. That's where we pick up. So we can take that black water, inorganics have been removed, the solids have been removed. We're then taking that water all the way to discharge standards or all the way to potable standard. We have other applications in different industries, especially in industrial applications. Manufacturers that use large amounts of water to produce their products.
So water at the inlet is pre-treated, but at the outlet it is reuse ready.
Correct.
How do you do that?
In our Faraday reactor, the process that actually cleans the water, so it kills all microorganisms at the cellular level. We essentially zap each organism with electricity. It creates holes in the cell membrane. That cell membrane is not able to repair itself. It collapses and dies. Any living organism is killed. And this non-discriminatory process is really important because we kill all living organisms, including the exotics, the E. coli's, the amoebas, the cryptosporidiums, the giardias, the ones that other treatments don't take care of, right? Fluorine doesn't kill everything.
Cryptosporidium in particular would take you to membrane treatments if you want to remove it. So does that mean you're one-to-one competition to membranes?
We believe we're in competition with anybody who's trying to deliver clean water, but we think we're delivering clean water more effectively. It's perfectly clean. There are no living organisms. UV has a challenge of high energy usage. RO is another process, but that removes everything, including the mineral composition of the water. You're now left with something that doesn't have any mineral content in it. It's not really water. We treat the water, kill the microorganisms, but we can leave the mineral content intact. We can also adjust that if phosphates or nitrates are too high, we can reduce those.
So where is the secret? Is it the reactor? Is it the way you apply the current? Is it some black magic you won't disclose?
Yes, in the reactor. There is not black magic, but science involved in this. But it's the proprietary technology that really makes us different. It sets us apart from others who are using other forms of electrochemical processes to clean water. The use of electricity in cleaning water is going to become more prevalent. Ours is the most advanced at this stage. It's the most effective, the least costly, and the most green, the most environmentally conscious way to go.
When you say most effective, do you have like figures to put a context to that?
So since we're killing every microorganism, that's more effective than chlorine. It's more effective than UV. RO is able to do the same thing, but at a much higher cost. So if you look at the effectiveness and the cost, we win on both counts. We're most effective and we're the least costly.
Water heavily pushes this use of energy in treating water and coined itself the Tesla of water treatment. But it's always challenging for me, and tell me about you in the comments, to make my opinion about a technology when I don't have hard figures to build upon, or a clear villain or challenge in the market, if you will, that the tech can reposition or take out. So let's try to figure out how water deals with that objection, and if I get their marketing materials right, the villain to reposition is chlorine.
Oh, I don't think there's a drawback in the technology. I think the challenge is to say, how do we convince people that chlorine isn't safe for us, that chlorine kills everything? We assume the water we drink is safe because there's chlorine in it. It's not. Not everything has been killed with chlorine. Chlorine shouldn't be consumed. We shouldn't swim in chlorine. It's not healthy for the body.
But chlorine is remnant, and if the regulation says that chlorine should be in water, then chlorine should be in water. So how do you overcome that?
So one, we have to help educate people on that. Why is it better to use our process than a different technology? As an alternative, you could say, well, use our technology and you have to have 2 parts per million of residual chlorine, put a doser at the end, and then demonstrate after 3 months of usage that before the doser, our water is clean every time. Turn off the doser. So there's a way to get around that. But yeah, right now, we have to work within the system. We're trying to help educate people so that the system can move with this technology. I'm sure the horse buggy manufacturers were really upset when cars came around, right? It disrupted their market. They pushed back. We're going to see the same thing here. We're going to disrupt the market. We're going to have people who are concerned that, hey, my technology is going to be replaced. Technology can't be stopped, right? It's going to go forward.
You've got spinned out 5 years ago. Where are you on that disruption journey? Where are you on the deployment of the technology, and how many installations do you have?
We're in the inflection point of growth. So we are addressing the real estate and aquatics market, big lagoons in the center of a real estate development or a surf park or aquatics park. We're in the wastewater and municipal space and the food and beverage. So we're at the inflection point where we've got applications and installations, and we're finding the customers who are the early adopters to get that leverage growth that we're looking for.
So your primary deployment place is a San Francisco or Austin type of place where a regulation enforces the on-site reuse of wastewater from a certain building size on?
That's an example of how the regulatory agencies are moving towards a new solution of water reuse. Governing bodies want to push this technology forward, make reuse more the way that we should be doing things. But the technology is the driver, not necessarily the regulation, right? We've got to push both at the same time.
Sorry to come back to that, but it's my catchphrase and I should print t-shirts with it. I don't believe in silver bullets, so I need to push a bit more here. Several of your applications, like aquatic parks, are a direct replacement or disruption, to use the big words, of chlorine. So let's count the points. You eliminate more stuff than chlorine, so 1 point for you. You don't have chlorine and its potential byproducts in water, so 2 points for you, I guess. But chlorine is the market workhorse for 150 years, so it's massively commoditized. Can you compete one-to-one on cost with chlorine?
Great question. So actually, the cost of chlorine has gone up about 50% since the pandemic. So the supply chain issues that affected a lot of products have also affected the chlorine market. 2, we don't have the storage of chemicals, the mixing of chemical issues that the typical chlorine plant does. Unfortunately, there's accidents all the time where the operator, the maintenance guy, mixes chemicals incorrectly and there's an accident. People can get killed. You don't have that issue with our technology. There's no chemicals, there's no storage, there's no mixing, there's no testing of the water for that. In fact, if you're going to store chlorine on site, you have to get approval from the fire department rather than from the regulatory agency. So there's another process to go through to get a permit to actually store chemicals on site. And then from an operational cost standpoint, we don't have to have an operator. Our system doesn't have moving parts. It runs on itself. We have remote monitoring technology, so you don't have to deploy the same number of staff to maintain the equipment and the water and the chemical storage that are associated with other systems.
So if you don't need an operator on site, what is your business model? Is it a CapEx sale or water as a service?
Our business model is to focus on design, build, own, operate, maintain, meaning we do the whole thing. You're going to deliver clean water to you as a customer every month. You're going to pay us that monthly charge. You can compare that against the cost savings of the water reduction, the chemical cost reduction, the energy cost reductions, and you're going to find our solution is much more cost effective.
Also, while I learned something, I hope I'm not the only one. Thanks a lot.
Thank you very much. Pleasure.
So here's for our second discovery of the day. And while I walk across WEFTEC again to go visit my third and last speak in this segment, I'd be curious to hear from you. My gut feeling is that there seems to be great on-scene and behind-the-scenes merits to water stack. But we would need to dig deeper into it to scratch beyond the surface of what you can discuss on a trade show. I have unanswered questions at this stage, and a new company on my bucket list of future deep dives, I guess. Now, a bit of context for number 3. PFAS was written all around the trade show, and while I knew of most of the approaches, there was still room for surprises. Next up, we'll have another way to tackle PFAS. Let's have a look at BioLargo.
So this little module here is an aqueous electrostatic concentrator module. The philosophy behind this technology was there are technologies out there which are good at capturing PFAS, ion exchange, carbon filtration, RO, but they all have downsides. And the biggest downside that we cared about right off the bat was the amount of waste that they generate, okay? So what if we could develop a technology which can capture PFAS while generating far less waste matter than those technologies, while also being effective at removing all the PFAS that we care about. The EPA, as you know, has released their drinking water regulations that name 6 PFAS molecules that have to be removed down to a certain level. 4 of them are long chain, I believe, and 2 of them are short chain. You need a technology that can remove both long chain and short chains. Carbon filtration and ion exchange, they're certainly great technologies that have their place in the world, but they do have some downsides. One of them is that they tend to have the short chains break through before you would want them to. I've seen studies done where short chains start to break through after 3 months even. And at that point, you need to start considering swapping out your beds, right? You have a problem there. You need to be able to remove all the PFAS of regulatory interest, and you need to not generate so much waste as a result of having to swap out that bed volume over and over and over again. So we developed this technology, which the whole purpose of it is to deposit PFAS onto a membrane that is as small as possible relative to the amount of water that you're treating. The way this technology works is it uses electrostatic separation. So PFAS in water passes through the system. PFAS, which are mostly negatively charged, or at least behave as though they are. If you apply an electric current, they're going to want to migrate towards the positive electrode, the anode. Before they get there, we place a membrane in its way. So rather than getting to the anode, they get captured by our proprietary membrane system, which is semi-selective for PFAS. So all the other ions are passing through the membrane, and our PFAS is not. It's sticking to that membrane like flypaper. Okay, cool. So now you have a system which can deposit PFAS on the membranes. Well, that's neat. You could do that with other technologies. What's special about it? Well, if you were to treat PFAS contaminated water with carbon, we generate approximately 20 to 40,000 times less PFAS-laden waste by mass after an equivalent amount of water was treated. So that's an extraordinarily small amount of waste after that amount of time. So rather than having maybe 80,000 pounds of carbon that you have to truck somewhere and landfill or incinerate, now you're only dealing with a few pounds. So that's great for the customer. It's also great for us because it's very flexible in how we can deal with that waste. You can incinerate it. You can theoretically landfill it. You can also destroy it with one of many terrific destruction technologies that are available. Waste, that's the thing number one. Less waste is generated. We also work on all PFAS that we've tested it against. It's pretty much indiscriminate in terms of the PFAS molecules, the analytes that it can remove. Short chain, long chain, doesn't matter. Some of the short chain, I will admit, are harder to remove, but if you increase the residence time and the voltage and current, you can still remove them with our technology. That's 2 things. The third thing I'll say that I like to brag about it is that it's very tolerant of poor water quality. You're not going to want to treat secondary wastewater effluent with ion exchange because it's going to get gummed up really quickly. Our technology, of course, it needs some pre-treatment, but we've used our technology to treat secondary effluent from wastewater. We've used it to treat RO concentrate, which is a rarity in this field, and even leachate with pre-treatment, I will say, which is great for us because that gives us more verticals that we can enter.
So let me put that in my own words to make sure I understand it. You apply a current and PFAS behave as if they were charged and get attracted to the anode. But before they reach it, you put a membrane on their path that catches them, and when that membrane is fully loaded, you extract it. How do you deal with PFAS elimination once it's trapped onto the membrane?
We understand that the waste handling for the customer is a big headache, it's a big regulatory issue, it's a big cost. So for us, we offer a membrane exchange program where once the membrane is saturated with PFAS, we can come and take away that membrane, give them a new one in a membrane exchange program.
What's the indicator that tells you it's at end of life?
The removal of PFAS is correlated really tightly with some other water quality parameters like conductivity. So once conductivity starts to change, we get clues as the idea that PFAS is going to start to break through long before it actually happens. It's kind of like an early warning system. And once we know that the PFAS is likely to start breaking through soon, we come and take away the membrane, give them a new one in a membrane exchange program. We take those membranes back to our facility in Tennessee, and then we can strip the PFAS right off of those membranes and destroy it in our facility. We favor electro-oxidation for that, but ultimately we're agnostic as to how that's destroyed.
What is like the bare minimum water quality that you require? Primary treatment, secondary treatment?
For wastewater, we have treated secondary effluent. I don't know, we can maybe go dirtier than that, but I don't want to promise something that we haven't done yet. I actually think that we could probably go dirtier than that, but secondary effluent is what we have treated, so that's all I should say.
And for drinking water?
We still require some pre-treatment, but I'll just say that it requires a lot less pre-treatment than you would require with carbon filtration or ion exchange.
So, less waste plus a broad spectrum of PFAS removal. Compared to activated carbon or ion exchange, how do you position yourself from a cost perspective?
If you're just starting with capital costs, Both footprint and capital cost, we're going to be very similar to both carbon filtration and ion exchange right off the bat. Now, where we start to pull ahead is operating costs, especially when we're in a context where waste is getting expensive. Today, with waste being regulated the way it is, operating costs, we do start to have a savings as the years go on. However, in a reality where that PFAS contaminated waste is regulated under RECRA, which we believe is going to happen, the cost of transporting and disposing of that PFAS-laden waste is going to go up. That's our hypothesis. So in that scenario, we're gonna the delta between our operating cost and, for instance, carbon filtration is going to be a lot better.
Let me put that in my words as well.
Sure.
Today you can dump your activated carbon in a landfill. Tomorrow you might first not be allowed to do it.
Yep.
But if you are, it might become super expensive, in which case the gap is going to increase.
Couldn't have said it better myself.
So, similar-ish CapEx, better OpEx, and potentially even better in the future. What's the drawback?
What's the drawback? Well, this is a relatively new technology, and nobody wants to lose their job because they were the ones to try out the new technology. So there's an inertia for accepting new technologies. That's why reference customers are super important, right? Thankfully, we have our first reference customer coming up in a small township in New Jersey. So we're very proud about that. I'll admit this is a small facility, but we're a relatively small company. And for us, small is maybe good for the first reference customer. So we're talking about a 50-gallon-a-minute system. And we believe that the results of that first system are really going to start convincing other more larger water treatment utilities to consider our technology as an alternative. And we also believe once the other shoe drops on the cost of waste, we believe that more people will come to us.
When do you go live with your first reference?
So we are under contract to deliver by November. That's assuming that the contractor who's supposed to build the building gets his job done in time, which we're very much hoping that's the case. Stay tuned on that one.
You mentioned you're a small team.
Yep.
How small?
Well, the company BioLargo overall is about 30 to 35 people. PFAS team, even smaller than that, of course. I think we have about 7 people who are on the PFAS team. So it's a smaller team, yeah, but small and mighty, I'll say.
Did you repurpose an existing technology, or did you develop specifically with PFAS removal in mind?
We developed it for this purpose. The technology was first a twinkle in our lead engineer's eye. He came to me and asked for help writing a grant application, because at the time I was doing a lot more work in grant writing. And he came to me and said, I have this opportunity to develop a technology for perfluoroalkyl substances. And I was thinking, oh great, another word salad, acronym contaminant that nobody really cares about. And it wasn't long before, Mark Ruffalo released his movie, Dark Waters, and I started to eat my words. My own mom will call me and say, have you heard about these PFAS things?
And what's the plan? Is it to become a PFAS treatment company, or a technology play that sells tech equipment, or license it out?
Generally speaking, our business model at BioLargo overall is to, we know what we're good at. And we're good at inventing new technologies. We're good at proving them up and developing them, doing the early commercialization, and then ultimately partnering to kind of extend the commercial reach of a technology. That's kind of our lane. So ultimately, I think that we're likely to want to partner to really make sure this technology gets installed in as many places as possible.
And for someone that would bump into you and got your 5-minute pitch, what's your call to action?
I believe that there's a misconception out there that in terms of the technologies that are available for PFAS capture, utility providers believe that there's options like carbon filtration, ion exchange, and RO. They don't know that there's innovation going on in the space of capture. I know that there's so much investment going on some incredible technologies in PFAS destruction, honestly. Those technologies are amazing. The investment in them is warranted, but I don't think people are aware that there's a lot of innovation going on in the space of capture, making capture more efficient. Because really, for those technologies to tick, you need to have a way to, the ratio of your water treated to the waste generated needs to be a very steep ratio in order for those technologies to be feasible. My call to action would be learn more about what innovation is going on in the space of PFAS capture, not just destruction. You don't need to just be relegated to only using carbon because you're told that it's the cheapest option. There are technologies out there like ours that are going to make your problem more economical, more sustainable, and more feasible in the long run, not just today, but 20 years from now.
As much as I hate to be the party pooper overall, today the EPA has a list of validated technologies, and their list is pretty short.
Yep.
It's activated carbon and ion exchange. So how do you make it to that list?
That's a great question. Isn't that the billion-dollar question? It's advocacy, and it's getting in conversations with the right people, whether they're in the EPA or thought leaders. Because not enough people know about our company yet and about our technology, and that's our job, really, to do the hard work, put the elbow grease in, and get people to be aware of our technology, at least as an option.
I guess it will help for that to have your first reference going live if all the stars align, and I'm touching wood for you in November. that might be a good stage to follow on your track and discover what's next in your pipeline.
Oh, thank you.
Hey, sorry to interrupt, but I wanted to use that transition to thank you. It's been amazing for me to walk the WEFTEC floor and get addressed by so many incredible investors, entrepreneurs, and water pros that were starting all the conversations as if we already knew each other, even if in many cases it was our first encounter. I crave that because that's something you might not know about me, but I'm super bad in breaking the ice. I mean, I can do it, I can handle, but I'm not a natural. So walking a 1000 booth floor can be a source of internal nervous breakdown for me, and you're helping me out so much when you do the first step and continue the conversation you feel we started over this video and podcast. So for the ones that are new here, welcome, make sure to subscribe, but also if you're new here, you might not know that this channel is my passion project. It's hours of weekends, evenings, and a good portion of my first ever Canadian Thanksgiving of editing to be able to push you this video just 1 week after WEFTEC. So it would be a great reward if you were to leave a thumbs up, maybe your opinion in a comment, and again, if you take it and share it with one colleague, one friend, your boss or your team. Honestly, that helps me so much in spreading the message. So thank you again, and to give you an example of what I mean here, here's to serendipity. I was walking the floor on the very end of the very last day of WEFTEC, arrogantly thinking I had now seen it all, when Jennifer tackled me in front of her booth to engage one of these genuine conversations I just referred to, and halfway through it, I was like, wait a minute, that's something I need to share with all of you. It's simply too interesting to stay between Jennifer and me. So here's what I learned from MentorAPM.
So we are just launching at WEFTEC our new asset collector and asset lens solution. And it is solving the problem of asset inventory and condition assessment. That's tedious, it's difficult, it's expensive, it takes a long time, but everybody's got to do it. We have created a solution that allows you to absolutely crush the time that you spend in the field and improves your accuracy and puts all the information into your system of record for you. Let's assume that you are trying to collect assets in the field that don't yet exist in your asset register. So you'd start with asset collector. You'd take pictures, add a nameplate photo, you'd take a picture of the tag, and you can very quickly just fill in the name of the asset. You can also capture the GPS coordinates. The system will read your photos and populate the field like your tag data and your asset plate data, and that becomes then the basis of your asset register. Building your asset register is really time consuming. It's something you might be paying a consultant to do. Now you can just send somebody out with pictures.
If I understood you right, that you can even do bulk collection. Like someone goes out, takes like 200 pictures, drops them inside the system, and the system will deal with it.
Yeah, we can batch process. Condition assessment is often like a big project that you're going to spend a lot of money on and a lot of time. You say, over the next 3 months, we're going to do our asset walk down and get everything. This allows you to actually have condition assessment be an ongoing thing so that you are constantly up to date. Because when you've done a big project that you've spent $500,000 on, you're not going to do that again next year.
I see different layers, which I'm interested in. Let's start with the first layer.
Yeah.
The magic.
Okay.
How does the image recognition work? What did you do? What is
Sure. We've got our pictures. Once we bring the pictures in, we have the opportunity to do 2 activities against those pictures. The first one is that we can assess condition. You select the pictures that you want to assess. You press assess condition, and in a batch, it reviews, assigns a score, assigns observed issues, and gives you recommended actions to take. This is the equivalent of doing up to, they call it a level 2 condition assessment, which is basically a visual assessment. Now, something that we're not showing here is that we can actually do thermography. You can have a small camera from FLIR or whatever on your phone. You can take infrared pictures, thermography pictures, and it will also give you a score and baseline condition assessment.
But already on that layer,
yes.
I mean, I look at the picture, I say, okay, it's rusty, but to me, it's uncategorized.
Yes.
As you say, severe rusting. I would expect that severe to mean something like this. Rating.
Sure. We work on a condition scoring scale of 1 to 5. 1 being pristine and new, 5 being horrible condition. This is calibrated against our condition libraries and asset models that we have in our system. So this is real. And actually, in testing, it has been proven more effective than the human eye. We had an image of of an asset that looked to be absolutely fine. The condition assessment came back and said it's leaking, there's rust, and there's spalding on the concrete. And when we zoomed into the corner of the picture in a shadow, we saw that ourselves, but we'd had to zoom in.
Is the image recognition algorithm something which is proprietary to you, or are you building on the shoulders of something which is existing?
We're building on a number of tools. We do have multiple models for validation.
If I get a 4, should I replace it straight away?
This is not going to tell you what to do. This is giving you considerations, what you should consider doing. When this is married with the whole asset management platform that MentorAPM offers, it does give you some more guidance on how you might adjust your preventative maintenance, what kind of intervention you would want.
When? So that means I can use that as a separate building block if I wish.
Yeah, no, this is available to anybody. So this is available to Mentor customers with our entire asset management enterprise platform. But this is a point solution that anybody with nothing or any other solution can use. Very challenging, time-consuming part is getting the plate data. Again, we can take a picture, batch process, fetch plate data. It reads this plate, drops it into the appropriate field, allows you to edit, double check if you would like, but the accuracy is proven very high.
So is that a V1 of something which will continue evolving?
So we've got amazing development that's still coming. You know, as I said, we've got the thermography part for the condition assessment. Another huge challenge for utilities is finding and attaching manuals, spare part lists, and everything.
I was going to that.
Yeah, that's not yet incorporated, but it's in development. Find the manuals and attach it to your asset record, attach your spare parts list. It's all ready to go for you there.
Find me a drawback.
A drawback?
Yeah. Why should I not use that?
Because you don't want to save money and time.
I had that conversation with VVater, who was doing image recognition, but inside the sewer. What they were encountering is end users who say, ignorance is bliss. If you now scan my entire network and are able to find all the cracks, because AI, as you said, and image recognition is better than the human eye.
Yes.
So you will see stuff
that you wish you hadn't.
And then if you don't have the budget to fix everything, now you know that you have all these assets which are ranked with a 5. Did you encounter a pushback like that?
I think it's just generally accepted that having condition information is better than not. Every utility has $100 of need and $10 to spend. So how are you going to spend that $10 best?
Where did you roll it out?
We are launching it here at WEFTEC.
You're launching on the back of an alpha. You have a couple of customers who already play with it.
So we have already proven it in the field with customers where we are using it. So it has been trialed, proven, but it is now commercially available, and this is launch.
So who should reach out to you?
Anybody who's responsible for a condition assessment needs to build out their asset inventory, collect attribute data. Anybody who's got that responsibility, whether it's a utility or an engineering firm doing it on their behalf, would love to speak with them.
And is that part of the product a Trojan horse, where you take it, it's so good that you want them to take a full MentorAPM experience?
We would love that.
That's a good salesy conclusion. Really love that. Thanks a lot for stopping me. I'm genuinely impressed.
Thank you.
There's another batch of genuinely impressive water innovations I'm bringing notes back home, coming from BlueTech Research and Imagine H2O's common selection of startups in the Innovation Pavilion. I've listened to pitches assessed by not-so-ferocious Crocs in the Croc tank and collected names and stories of people that may make it to the podcast in the coming weeks and months. Did I remind you to subscribe? Oh, yes, I think I did. But before adding more companies to my roster, it's time to follow up with a couple of alumni of the podcast, starting with Ori Reshef, Kando's Chief Solutions Officer, who had made me a promise.
Come to our booth, come to WEFTEC, check out STREAMi, check out what it ignites in you. We're looking for people that have an open mind and a passion to explore.
So the way to try out STREAMi is to come visit you at WEFTEC at your booth.
Yes, definitely. And for you especially, you'll get a URL. Once we're building a separate environment that is separate from our customers, you'll be the first one to use it.
Appreciate. So did he stay true to his word? Let's find out. So I finally get to meet STREAMi.
Yes, exciting. You know what? You do it yourself. The most important thing is for us to keep STREAMi as professional as possible and not hallucinate. So we build those guardrails very strictly. So she stays in the domain of knowledge of Kando. And when it steps out from the domain of knowledge of Kando, it will ask you politely the questions. Why won't you try it yourself? We start off with a conversation starter. So hopefully the internet will work nicely here. So
I'm curious. Now I want to know who are your main polluters.
It goes to the database. We took the customer's data and obfuscated it.
Maybe that's important. I'm not playing around with data I should not access. This is an authorized demonstration, okay?
Internet is down.
And it's a trade show. Those things happen.
There you go. Actually worked.
That was fast.
Yeah. So you have the facilities identified, South Metal, South Food with everything, the area, the sector. Now you can ask questions about this facility. So, please go ahead.
I see pollution percentage. What does pollution percentage mean?
Interesting. I never asked the question. Oh, there you go.
The pollution percentage represents the proportion of time a facility's discharge exceeds acceptable pollution limits. Wow. So that means that my contributor here, South Metal, who's having 79% pollution percentage, is above its rejection rate.
Yeah.
79% of the time.
STREAMi has all the regulations down to the regional level and also down to the permit level per industry.
So, I'm mad because that guy is polluting 79% of the time. Write me an email for that South Metal polluter. He needs to stop.
STREAMi will know you're angry.
Oh, that is. Urgent action required, reduction of pollution levels. So basically something which would have taken me half an hour of second guessing because, you know, I'm writing it and saying, oh, I'm maybe too nasty or I should be...
Exactly.
And here I have a draft. I can rework it in maybe 2 minutes to add my name and I'm done.
And you can actually prompt them. The name of my recipient is Joshua and I am Antoine. Please include it there. And you can actually set the tone. You put an exclamation mark so it sets the tone, but you can even go further.
It's a long-time polluter, so I'm not happy with him.
Okay.
But he has a good neighbor, so I want to name and shame. So I'm gonna say, find me a neighbor who is doing better so that I can name and shame South Metal. I'm pretty sure that is an absolute common use case of STREAMi. Maybe not. Maybe not.
Maybe after this one, yes.
Oh yeah, we have this South Pharmaceutical facility who's polluting only 61% of the time. So it's much better.
It's much better.
Beyond the joke, the level of sensibility, like saying, yeah, they're polluting more, but there's a trend upwards, but it's still, I mean, it's more than last month, but it's still better than the other. That's super cool.
So that's what blew our mind in combining our data. So STREAMi talks to Kando and understand we have the trends, we have everything. And we told her in the instruction side, this is how you should compare, this is how you should rank, this is how one of our subject matter experts will look at that.
It works. I have seen it with my hands. Now, if I'm not at WEFTEC and I'm not on your computer, when will you have a STREAMi Lite available?
Okay.
Is that on your roadmap?
Surprise.
Oh.
We thought of you. And kudos to Aviv Nizri that produced it on our side. I will send you a play version.
Okay.
We call it the STREAMi sister. It's her sister. It's not exactly STREAMi because we don't want to give you data.
Yeah.
No, of course.
Still the concern about you don't play with data which is not yours. Makes fully sense.
Exactly. Write your email.
Done.
Done. Can you check your email now?
I have it.
The link. Enjoy.
Great meeting you at WEFTEC. I invite you to try out GenAI solution for the... Oh, I have access to it. Trust me, I'm going to try the hell out of it. When we discussed, you mentioned your long-term vision where STREAMi becomes kind of the interface for Kando.
Yes.
Do you have a roadmap for that?
Yes, sure. The idea is to go mobile first, to give something that is very accessible and very business-oriented. Our users will choose their business goal, for example, reduce the treatment plant costs, and we'll understand what are the potential savings, which is a huge motivation. You can help your organization using Kando, using quality, because as we discussed, quality is the business of everybody and the responsibility of everybody.
So you're driving from the money, you're driving from the end results.
Yes.
And then it will inform the actions.
Exactly. It's a kind of a geo-economical reasoning, showing them which are the regions or areas that have the greatest potential for savings. We pick one up.
Let me bring you closer.
And we see the impact of each and every industry in this specific region to reach the goal. So I'll pick the biggest one. And STREAMi will be like your very smart and sometimes annoying assistant saying you, hey, Antoine, you didn't do that. I prepared the presentation. All you need to do is 1, 2, 3, 4, 5. Please do it. Or the samples are ready. Or look, I analyzed the results. This is it. You can now go talk. So that's our roadmap. We're selling this already. So if customers are interested in using that and trying that out, they're they're more than welcome.
You're out there proposing that actively to customers?
Yes.
And if someone walks the floor of WEFTEC, signs a contract, when can you roll out?
3 to 6 months, it's out.
That is fast.
We work fast.
That is fast. Well, super cool. Thanks a lot for
Antoine, it's
the hands-on.
It's a pleasure meeting you finally face-to-face.
And the face-to-face was cool as well. So.
Yeah.
And yes, indeed, Ori's been true to his word. I have access to STREAMi's sister. And as none of the companies I'm telling you about today has paid me a cent by any stretch of the imagination, I'll play around with it and will update you in the coming weeks with a honest review. But for today, we have a last stop. Remember how BioLargo was removing PFAS just minutes ago? Well, BioLargo is of course not the only company here to tackle PFAS. It's written pretty much all over the places. But that was also the opportunity for me to take some news of a company you've heard on the podcast 3 years ago, Axine, because actually they have some great news to share when it comes to PFAS elimination. You've led to WEFTEC with an exciting press release officializing your first commercial-scale PFAS destruction reference with Lax Enterprises in Grand Rapids, Michigan. First, congrats, and second, is that a soft pivot for Axine?
I think it was a pivot for sales and marketing strategy, but not a pivot for the company. We still see ourselves as a contaminant destruction company. So contaminants for us could be an active pharmaceutical ingredient, it could be a solvent, it could be PFAS. It's going to be contaminants of the future as well. We see that this can change over time, and that's what we're there in order to treat that water coming out.
So tell me about that first PFAS commercial reference.
We are treating PFAS water with Lax Enterprise. PFAS is a critical component of their manufacturing process. They concentrate that water, or the PFAS water, and then we treat it on our side, and then it's safe for discharge after. We're really looking forward to setting up the first install, probably a little bit later on this year or early 2025.
Why did they go for PFAS destruction when they could have stayed with PFAS removal?
Absolutely, and then it's somebody else's problem, right? I think in the long run, you know, the beauty about destruction technologies when they first come in to treat that wastewater is that, yes, it's today that we're destroying PFAS because that's the primary one that everyone is concerned with. But we're also going to treat other contaminants that's going to be in that water in the future. So these guys have now taken control of their manufacturing process. They've taken control of how to deal with their waste. So they're not going to be dependent upon third-party providers coming in order to ship that water off. They're not going to have to worry about increasing costs over time or anything like that. They have the control with us, treating that water on site for valuable discharge at that point.
So it's a matter of control. That's a decisive criterion.
The way we pitch ourselves to industrial manufacturers, don't change your manufacturing process. Chemicals are going to be an essential part of what you do, no matter how you do it. You could get substitutes for a particular chemical, but maybe that substitute is going to be a problem down the road as well. Treat the chemical at the end of the process, manufacture your core products like you normally would, and we'll take care of treating the water for you so that you can have the safe discharge in the long run. In my view, yes, this is a big strategic value for a lot of these industrial customers. They're taking the fate of these contaminants into their own hands.
You're doing treatment as a service.
We are.
So here you're doing PFAS destruction as a service.
Yeah.
I'm told you have more potential PFAS destruction references in the pipe.
Yes.
How positive are you about that, and what can you share with me today?
When we made our, let's say, pivot of sales and marketing efforts towards PFAS, we made a very pronounced effort to get as much water from as many different sources as we could. So we've got water from landfill leachate, we've got water from groundwater, we've got multiple industrial water samples, we've tested water from foam fractionation, so foamate, we've got water from ion exchange regenerant. But the whole idea is to put together a library of our capabilities and to show that it doesn't matter what source the water is coming from. If it's PFAS, we can treat it, we can destroy it, and we can go down to whatever the regulatory requirements for our partner is. Yes, we have more water coming in for testing. We have more pilots getting lined up. We're going to do pilots with different industrial manufacturers, pilots with different water segments. This data is all going to start coming out in 2025. We're very excited. And the other part too is that we're going to be forming critical partnerships that are going to enable us to go into different segments and different territories that we haven't been in before.
What are typical partnerships for you?
That's an area where I'm going to be very, very careful on answering, right? Some of the partnerships I could go into more detail. Probably some of the more critical areas that we want to go into is partnerships with concentration providers, where we could go out to customers and offer not just destruction, but concentration, so separation of the PFAS out of the water, coupled with destruction, all in one service offer. Probably as
someone does the ion exchanger, someone does the reverse osmosis, whatever it is to concentrate, and then you destroy.
Exactly, but coming in with the full service package. That's what we want to actually offer. So those are key strategic partnerships. The other part is probably going to be more on the sales partnerships for accessing different segments that we aren't currently accessing right now. And that's probably as much detail as I could go into at this point. But we should do another interview next year and I'll go into many more details at that point.
Is PFAS the headline and the other lines are still in the news, or is PFAS the sole focus?
PFAS is the one that folks like you and people around this conference want to hear about right now. But the pharmaceutical market, the antibiotics that are getting into the wastewater, 1,4-dioxane, all of those other contaminants, just as equally important, but just not as, I guess, media catching as what PFAS is right now. So yes, we're definitely going to be in the space for treating PFAS. We're going to be there, but we're also going to be there for treating all of the contaminants for other customer segments as well.
I've spent the first 7 years of my career in micropollutant removal, so tell me about it. But regardless of the trace compound you aim to eliminate, what would be the 2 killer arguments to go for Axine?
So just 2.
Yeah.
All right, effectiveness. Look at our results. We publish our results on our website. We put it into our case studies. We put it into our documentation here on the table. We will show you what we can treat and how we can treat it for every contaminant, whether it's PFAS or other chemicals that we're looking to do. And it's all going to be in the published domain. So we know we could treat it. Send us water. We'll treat your water and show you the results from that as well. So that's the first component. You should actually make sure that whoever you use for destruction can actually treat the water to the limits that you need to get. Number 2 is going to be our commercial experience. It's all very easy to say, all right, you could go out and you can do pilot studies, you can do lab-based studies, that's fine. But when you're treating water 24/7, 7 days a week, 365 days a year, it's a totally different ballgame. These are all factors that we've been using since 2017 in our commercial operations, and we're going to bring to the customers that we're talking to today.
So those were the 2 advantages. Now the tricky question which comes with that, what is the drawback? When would you say, no, don't go for Axine, pick something else?
So biosolids, if you have a mixture of water with high particulate samples or high particulate matter in it, we're going to need quite a bit of pre-treatment in order to get the aqueous phase of that coming out. But then you still probably have, with the solid material, a certain amount of PFAS contamination. That's not the best system for us. Maybe going to supercritical water or maybe going to an incinerator, maybe that might be the better option for like a biosolid. But otherwise, I think you should always come and try us out.
Thanks for taking the time for this update.
Antoine, thank you very much. Always great talking. Hopefully we get to do it again. Well, we're going to be having some big news, I think, come out in the next month or so. I think it might be a great idea to connect again, maybe in the not too distant future.
Boy, that was intense, but it's not everything there is to it, because I recorded more here and in New York 2 weeks ago. So if you don't want to miss out on those bits and pieces, make sure to subscribe and I'll see you next time.